Hello class, today we're doing a test review for your test tomorrow. Our entire test is over just slope and y-intercept. So that means for the entire test, you're going to be using the formula y is equal to mx plus b. Where we know to find m, our slope, we have several different ways of finding that. We can find it using this little chart right here. From a graph, we know we're going to use rise over run or fall over run if it's a negative slope. From a t-chart, we're going to use delta y divided by delta x, or the change on the right-hand side divided by the change on the left-hand side. If it's just given 2 points, we're going to use a formula to find our slope. And we also need to know that slope is the same thing as rate of change. So if you hear that phrase, then we know that we're looking for slope. Okay, so let's see if we can do the answers to this test review. So on the first question, all I asked you is what is slope and y-intercept? So we look at our formula here, y is equal to 5x plus 3. Well, we know that's in the same thing as y is equal to mx plus b. My m is my slope, and my y-intercept is my b. Now this 5 could also be represented as 5 over 1, and that would be fine as well, because we know slope is a fraction. Now from a t-chart, we know that we're going to use our delta y divided by our delta x. So delta y is plus 5, our delta x is plus 1. That didn't look right. It's plus 1. So 5 divided by 1, again, our slope is 5, or 5 over 1, because 5 over 1 is our slope as a fraction. Now our y-intercept is going to be the y value when x is 0. So our y value is 12, so our y-intercept is 12. Now number 3 is going to be the hardest question on the test, because we're trying to find slope and y-intercept when only given 2 points. Well, in order to find the slope from this one, we must use our formula. M is equal to y2 minus y1 divided by x2 minus x1. Now, in order to do this one, I gave you a series of steps to follow. Okay, the step number 1, identify your points as 1 and 2. So I'm going to call this one point 1, this point 2. Okay, so that allows us to say that my negative 4 is going to be my x1, my 6 will be my y1, my negative 2 will be my x2, and my 0 will be my y2. And then I just plug my values into this formula. Okay, so y2 is 0 minus y1 is 6 divided by x2 is negative 2 minus x1 is negative 4. And we do our math. Okay, so 0 minus 6 or 0 plus negative 6 gives me negative 6. And negative 2 minus negative 4 or plus positive 4 gives me 2. So negative 6 divided by 2 simplifies to negative 3. And that's my slope. Now the y-intercept is a little bit more difficult to calculate. What we're going to do is we're going to use the y equals mx plus b formula to calculate our b. Okay, now we just found slope, which we know represents the m. So we could plug in the negative 3. Now, the x and the y, we're going to choose one of the points in our problem and substitute the values in for x and y. So the first one, I'm going to use the negative 4, 6. Okay, so my x would be a negative 4. I'm looking for my b. My y is 6. So now I solve. So 6 equals negative 3 times negative 4 gives me positive 12 plus b. Now to get b by itself, I add a negative 12 to both sides, and I end up with b is equal to negative 6. Now what if I chose the other point? Would I get the same answer of negative 6? Well, let's just see. Let me erase this, and we'll try again. Okay, so now I plugged my m in, my slope in is negative 3, and we'll use the negative 2, 0. Okay, so my x value is negative 2, my y value is 0, so I get 0 is equal to negative 3 times negative 2 gives me 6 plus b. Now to get the b by itself, I add a negative 6 to both sides, and you find out that b is truly negative 6 with either point. Okay, so it doesn't matter which point you choose, you still get the same answer. Okay, so again, to find that y-intercept, once you found your slope, you plug your slope into the m value and the m spot into the y equals mx plus b, and then plug your x and y values into their appropriate spots and solve for b. Okay, so let's continue with the test review. Okay, number 4. When the data from the table are graphed on a coordinate grid, the points all lie on the same line. What are the slope and y-intercept of this line? So number 4 is exactly like number 2, just has more words. Okay, it says, what's the slope? We know from a t-chart, we're going to find our delta y, which in this case is -3, and our delta x, which is +1. -3 plus 1 is -3, or -3 over 1. And our y-intercept is going to be the y value when x is 0. So our y-intercept is 2. That's simple. Number 5, you're asked to do the same thing. It's just we have to then plug it into the y equals mx plus b format. Okay, so let's find our slope. Find our delta y is +4 or +4. Our delta x is -2. So 4 divided by -2 gives us -2. So this gives us a negative slope. Okay, now the y-intercept, we come down here to our x is 0, our y value is 6. So we end up with a slope of -2 and a y-intercept of 6. Now what do I plug in with the x? Well, we know the slope always goes with the x. So -2 and 6, just like that. Number 6. Now this one's a little bit different. It's still a t-chart, but this t-chart is horizontal. Okay, so we've got to make sure we understand what our x and our y is. 99.9% of the time, the top is going to be our x, the bottom is going to be our y. So in a t-chart, we do delta y, which is the bottom. Okay, from 0 to 4 is +4 divided by the x, okay, which in this case is the top, which is +1. So 4 divided by 1 is 4. Now this one asks for a rate of change. What did we say rate of change was? It's just the slope. So it's going to be 4 over 1 or 4. Now the y-intercept is going to be the y value when x is 0. So I look up here on the top, where's x 0? What's the y value? Also 0. So I plug those into the equation. Rate of change is slope. That is our m value. It goes right here. And our y-intercept goes at the end. So we end up with an equation of y is equal to 4x plus 0, or just 4x. And number 7, we've got to find slope and y-intercept from a graph. Well, the first thing I've asked you to find is y-intercept, the place in which the graph crosses the y-axis, which is right here. So I count up 1, 2, 3, 4. So my y-intercept is 4. Now to find my slope, I look for 2 good points. In other words, 2 points that cross at the crosshairs. So the one that I just used, the y-intercept, is the first good one. Okay, and I can go up, here's another good one right there. Now how did I go from one point to the next? Well, I went up 2, and I went over 1. So when I do the rise over run, that's 2 over 1, or just 2. Either one would be acceptable. Okay, now for the equation, we now have to plug those into the y equals mx plus b format. So our slope goes with the x, our y-intercept goes as the b value. All right, now that's where we're just finding slope and y-intercept. Simple as that. Now we have to do the application of it. Okay, so what does this mean? How do I interpret it? Well, number 8 says the graph shows the relationship between the amount of sales Mr. Henderson makes each week and the amount of money he earns at the grocery store. Okay, so we've got amount earned for our y value and the amount of sales as our x value. Okay, so we got to look for our y-intercept. Well, again, it's the place where it crosses the y-axis, so that's right here. So the y-intercept is 1,000. Okay, now we've got to look for the slope of the line. Now the slope is where we look for good points. Okay, so I find this y-intercept as one good point, and then I look for the crosshairs. Here's another good point, here's another good point, and so on. We find out how did I go from one point to the next. So it says I rose one line, but we have to make sure we understand what that one line means. That one line is not 1. Okay, that one line is halfway in between 1,000 and 1,500. So that line really represents 1,250. Okay, so what's the distance that I traveled? I traveled 250. Okay, and then run. Well, we think it might be 2, but those 2 lines, again, we've got to look at our scale. Well, what did our scale here represent? Those 2 lines is actually 5,000. So now we have to simplify that. So there's a couple ways you could simplify it. You could do it by hand. Divide out the zeros and then how many 25s in each of those. Okay, and you're going to find out that there's 20, okay, 25s in 500. Or you could just type that into your calculator into the fraction form. 25 divided by 500 equals, and it's going to simplify down to 1/20th. The decimal for that is 0.05. Okay, so the slope of the line is either 1/20th or 0.05. And then we plug that into the equation, and we know that the slope is going to be in this first blank. So 1 over 20, because I like my slope to be as a fraction, even though its equivalent is 0.05, and its y-intercept is 1,000. Okay, the second one, number 9. The graph models the value of a machine over a 10-year period. So if you have a machine, the moment you buy it, it's going to start devaluing. In other words, its value is going to go down. And that's what this graph represents. So according to the graph, what is the rate of change? Again, rate of change, our slope. Now in this one, our slope is kind of interesting. Okay, so let's take a look at it. So I'm going to find 2 good points. Here's a good point, here's a good point. At this one point, we know that point's going to be the y-intercept. So I could look down there. Do I need that? Yes, I do. The y-intercept is 8. Or is it really 8? What does it really say? That 8 really is not just 8, but that 8 could actually be 8,000. Okay, so that could be an 8,000 as well. And we'll look at this equation both ways. Now, how do I look at the rest of it? Well, it says it goes down. So it goes down 1 or 1,000. 1 or 1,000. And it runs 2 lines. But what does the 2 lines represent? Oh, it does actually represent 2. Good. Okay, so 2. Now that 1, it's actually a negative because it goes down. So this 1,000 is actually a negative because it goes down. And then it runs 2. So we could say that that's either down 1/2, okay, down 1 over 2, down 1 over 2, okay, or I could say this is down negative 1,000 over 2, which actually simplifies to negative 500, which represents $500. Okay, so our rate of change then, or our slope, can be one of 2 things. It could either be negative 1 over 2, okay, if all you looked at were the numbers, or it actually could be negative 500, however you interpreted it. Now, if we use the negative 1/2 as our slope, you must use the 8 for your y-intercept. If you use the negative 500 as your slope, then you would use the 8,000 as your y-intercept. Okay, so it does make a difference as to which one you do. You can't mix and match them. Okay, so you could either have negative 1/2 x plus 8 or negative 500x plus 8,000. And they would represent the same thing on this particular graph. Now we got one last question to deal with. Okay, now this one goes back to almost like the first question. What's the slope in y-intercept? Now we need to remember the slope is not always the first number. The slope is the number that is with our x. So in this case, our slope is 3 over 4. And our y-intercept is the number that's by itself, which is the 2. Now I ask you to graph this. Now, when I ask you to look at a graph, I ask you to look at the y-intercept first. Well, that's the same way I want you to graph it. Look at the y-intercept, because it says that my graph's going to cross at 2. So I put a dot at 2. Now, the reason why our slope is in the form of a fraction is because it represents rise over run. So it says from that point, from the y-intercept, I'm going to rise 3, and I'm going to run 4. And we're always going to run to the right. So I rise 3, 1, 2, 3, and run 4, 1, 2, 3, 4, and put a dot. Now you must have at least 3 points. So 1, 2, 3, 1, 2, 3, 4, put a dot. Now you can even go backwards. Instead of a rise, I go 1, 2, 3, I fall, and then I run the opposite direction. 1, 2, 3, 4, and you'll be on the same line. Now to finish this one out, we play connect the dots, continue it out both sides, and place the arrows. And that's how you're going to pass this test. So please study this, look over it, make sure you understand how to find slope and y-intercept from a graph, from a t-chart, and from a situation. Good luck. Until next time.